Listening, fill in the blanks.
Let's start.
Research has shown that laughter is more than just a person's voice and movement, and that it requires the coordination of many muscles throughout the body. Laughter also increases blood pressure and heart rate, changes breathing, reduces levels of certain neurochemicals, catecholamines, hormones, and provides a boost to dying immune system. Can laughter improve health? It may be a good way for people to relax because muscle tension is reduced after laughing. Human tests have found some evidence that humorous videos and tapes can reduce feelings of pain, prevent negative stress reactions, and boost the brain's biological battle against infection. The scans also showed activity in the nucleus accumbens, which is likely related to our feeling of mirth after hearing a good joke and our addiction to humor. While his research was about humor, the results could help lead to answers and solutions to depression. Parts of the brain that are active during humor are actually abnormal in patients with depression. Eventually, brain scans might be used to assess patients with depression and other mood disorders. The research may also explain why some stroke victims lose their sense of humor or suffer from other personality changes. The same part of the brain is also associated with social and emotional judgment and planning.
Tickling is caused by a light sensation across our skin. At times the light sensation can cause itching, however, most of the time it causes giggling. If a feather is gently moved across the surface of the skin, it can also cause tickling and giggling. Heavy laughter is caused by someone or something placing repeated pressure on a person and tickling a particular area. The spots tickled often are feet, toes, sides, underarms, and neck, which cause a great deal of laughter. Yngve Zoderman from Karolinska Institute has found that tickling sensations involve signals from nerve fibers. These nerve fibers are associated with pain and touch. Also, Zoderman has discovered tickling sensations to be associated not only with nerve fibers, but also with sense of touch, because people who have lost pain sensations still laugh when tickled. With weather and temperatures set to become ever more unpredictable due to climate change, researchers say the discovery that this light-sensing molecule also functions as the internal thermometer in plant cells could help us breed tougher crops. It is estimated that agricultural yields will need to double by 2050, but climate change is a major threat to achieving this. Key crops such as wheat and rice are sensitive to high temperatures. Thermal stress reduces crop yields by around 10% for every 1 degree increase in temperature, says lead researcher Dr. Philip Wigg from Cambridge's Sainsbury Laboratory. Discovering the molecules that allow plants to sense temperature has the potential to accelerate the breeding of crops resilient to thermal stress and climate change.
Grossman and his colleagues have also found that one of the most reliable ways to support wisdom in our own day-to-day decisions is to look at scenarios from a third-party perspective, as though giving advice to a friend. Research suggests that when adopting a first-person viewpoint, we focus on the focal features of the environment, and when we adopt a third-person, observer, viewpoint, we reason more broadly and focus more on interpersonal and moral ideals such as justice and impartiality. Looking at problems from this more expansive viewpoint appears to foster cognitive processes related to wise decisions.
In another study, couples in long-term romantic relationships were instructed to visualize an unresolved relationship conflict either through the eyes of an outsider or from their own perspective. Participants then discussed the incident with their partner for 10 minutes, after which they wrote down their thoughts about it. Couples in the other's eyes condition were significantly more likely to rely on wise reasoning, recognizing others' perspectives and searching for a compromise, compared to the couples in the egocentric condition.
Since then, so many other examples have been discovered that it no longer makes sense to say that evolution is as good as irreversible. And this poses a puzzle: how can characteristics that disappeared millions of years ago suddenly reappear? In 1994, Rudolf Raff and colleagues at Indiana University in the USA decided to use genetics to put a number on the probability of evolution going into reverse. They reasoned that while some evolutionary changes involve the loss of genes and are therefore irreversible, others may be the result of genes being switched off. If these silent genes are somehow switched back on, they argued, long-lost traits could reappear.
The Uffington horse is also surrounded by Bronze Age burial mounds. It is not far from the Bronze Age cemetery of Lambron Seven Barrows, which consists of more than 30 well-preserved burial mounds. The carving has been placed in such a way as to make it extremely difficult to see from close quarters, and like many geoglyphs is best appreciated from the air. Nevertheless, there are certain areas of the Vale of the White Horse, the valley containing and named after the enigmatic creature, from which an adequate impression may be gained. Indeed, on a clear day, the carving can be seen from up to 30 kilometers away.
No greenhouse gases are produced, but the system needs some additional features if it is to be environmentally friendly. Dr. Prue Chopra, a geophysicist at the Australian National University and one of the founders of Geoenergy, note that the steam will bring with it radon gas, along through a heat exchanger, and then sent back underground for another cycle. Technically speaking, hot dry rocks are not a renewable source of energy. However, the Australian source is so large it could supply the entire country's needs for thousands of years, at current rates of consumption.
Turning her attention to minerals, she found her interest drawn to pitchblende, a mineral whose radioactivity, superior to that of pure uranium, could be explained only by the presence in the ore of small quantities of an unknown substance of very high activity. Pierre Curie joined her in the work that she had undertaken to resolve this problem, and that led to the discovery of the new elements, polonium and radium. While Pierre Curie devoted himself chiefly to the physical study of the new radiations, Marie Curie struggled to obtain pure radium in the metallic state. This was achieved with the help of the chemist André-Louis Debierne, one of Pierre Curie's pupils. Based on the results of this research, Marie Curie received her doctorate of science, and in 1903 Marie and Pierre shared with Becquerel the Nobel Prize for Physics for the discovery of radioactivity.